Hi folks, welcome back to the fourth and final installment for 10.2 Ellipses. So we're going to take a look at some questions now where we are trying to write equations for ellipses. We spent a lot of time graphing them and visualizing them, and now we want to be able to sort of go backwards. How do we construct the equation given some different pieces of information? So let's start with question number 9. And we want to note that we want to find an equation that has an ellipse at the center. The origin is at the center. So we don't need to worry about h and k. All right? So let's go ahead and write the general form of the ellipse equation, which is x squared over a squared plus y squared over b squared equals 1. And so our job is to figure out what our a and b are. And that requires us to know where our vertex and our vertices are and our co-vertices. So I like to take the information and actually just dump it right onto a diagram. Why not? So I'm going to take my vertices. I know that I have plus or minus 8, 0. So I have a vertex here, and then I have another vertex out here. Now, since these are the vertices, this distance is really my a. So a equals 8. All right. Now, the other piece of information they tell us is where the foci are. And they say that those are at 5 and negative 5. Now, the distance between the center and the focus is C. All right, so that's not B. And let's just remind ourselves the center's there. Okay, so what we need to do now is we need to be able to find B. Well, guess what we're going to use? C squared equals A squared minus B squared. So we have C equals 5, okay? So 5 squared equals 8 squared minus B squared. That's going to give 25 equals 64 minus B squared. And that B is going to be the square root of 39. Okay, that also means that B squared is 39. And that's actually nice because we want B squared for our equation. So let's fill in all the information we have. We have x squared over 8 squared plus y squared over 39 equals 1. Or we could also write it x squared over 64 plus y squared over 39 equals 1. Either option is fine. All right, let's move on to question number 10. So question number 10 says, I have different information, all right? But I'm going to start the same way, and I'm going to write out the general form of my equation so I know what I need to fill in. Okay. So again, they tell us where our vertices are. They tell us that our vertices are at 0, positive 5 and 0, negative 5. Now those are in the y direction. So this distance right here, okay, is our A, and that is actually going to be 5. But we want to put this number under the y, okay? It's really not as important what's A and what's B as it is what's up and down and what's side to side, okay? So if it's confusing to you, you can just make this into a B, but I think it's more helpful to keep it as A for our equation up here. All right, what else do they tell us? They tell us that the minor axis length is 3. That means that the co-vertices together, the whole distance in between them is 3. Now that means that our B value, or our co-vertices distance, is 1.5, or half of that. Now, we just need to fill in all that information into our equation. So x squared over 1.5 squared, because that's the horizontal distance, plus y squared over 5 squared, because that's the vertical distance, equals 1. Now, if you wanted to, you could certainly square the bottoms. That would be 2.25 plus y squared over 25 equals 1. Okay. All right. Let's take a look at question number 11. So question number 11 says that we are given where the foci are, and we are given the minor axis length. So again, I know my center is here. The foci are plus and minus 3, so plus 3 and minus 3, and that distance is definitely C. Now the minor axis length is 2. Well, how do I know which direction it's going in? Well, if the foci are going side to side, the minor axis length is up and down. So I know that here and here, together, this distance is 2. So I know that the number under y is 1 squared, because half of 2 is 1, and then I have to square it. So let's write our general form, x squared over a squared plus y squared over b squared equals 1. So I have x squared over, I don't know where the vertex and the vertices are yet, so I have to leave that blank, plus y squared over 1 squared equals 1. But I can use this information to find my a distance. So c squared equals a squared minus b squared. So 3 squared equals a squared minus 1 squared. So 9 plus 1 equals a squared, so a squared is 10. And so I can put a 10 underneath that fraction. All right. Let's do one last example here, number 12, and we'll leave number 13 for you to practice on your own. All right, so number 12 talks about something called eccentricity. So if folks are wondering, well, like, does it matter how ovally an oval is? That's what eccentricity means. But it also gives you the ratio of C over A. Okay? So C over A tells you how eccentric an ellipse is. Let's start off with a diagram. I know that my vertices are at 0, 4 and 0, -4. So I'm going to go ahead and write underneath my y squared, I'm going to go ahead and put a 16, 4 squared. Now, the eccentricity means that my foci are at -3 and +3 because of the ratio 3 over 4. Now, that doesn't help me find out my co-vertices, but like example 11, I can use c squared equals a squared minus b squared to figure it out. So c squared is 3 squared equals 16 squared minus b squared. And this is going to give me b squared equals, oh sorry, not 16 squared, 16 minus 9, which is 7. Okay, so underneath x, I can put 7. And what that means is that my co-vertices are like square root of 7 and negative square root of 7. All right. So that's it for 10.2. You can see a complete answer key in Canvas, so be sure to check that out. All right, see you later.